Lab guy here. The deflection board is finished and major assembly of the final product of the Chief has begun. Today I'm going to show you the highlights of what I've accomplished so far, and we'll look at each piece and I'll show you how it all fits together. So let's get on with it. First, let's look at the 3D printed stack with the 2F21 monoscope tube and deflection yoke installed. As you recall, there's the support ring that supports the tube by its bell. On the side is a contact for the collector electrode, which turns out to be the internal coating of the tube, and its job is to collect secondary electrons that the electron beam will knock off of the target as it scans it. This electrode is right here. I have a nice spring contact to touch the side of the tube to make contact. There is a noise bypassing capacitor right here and a wire running down through the stack and into the main chassis where it is tied to the high voltage power supply. I've installed the deflection yoke, which was previously on the Cyclops. I've installed it into the frame now and clamped it down. It's very likely it's not oriented correctly. It will need to be rotated around to make it square with the test pattern inside the tube, and that test pattern is currently invisible because the tube is painted black. We're now looking at the underside of the main chassis. The AC wiring coming in from the entry module has been connected to all three power transformers, is distributed by a nice terminal strip to a 3-position power switch, which will function as the off, standby, and full on power switch. In the standby mode, power is only applied to the filament transformer or heater transformer to warm up the heater in the tube before we apply DC power to the rest of the system. That way the tube is fully warmed up when we begin operating it. The high voltage power supply has been mounted and wired to the tube socket at the bottom of the stack. The controls are installed on the case, and for review, the controls are beam, focus, and shading. The beam controls grid 1, adjusting how much electron beam is generated. The focus control focuses the electron beam onto the internal metal card that contains the test pattern, and the collector inside the tube, which absorbs the secondary electrons, can be adjusted here. Its voltage can be adjusted here by the shading control. Power consists of the 6.3 volt 2 amp center tap transformer for the heaters in the tube. This transformer is a 32 volt AC transformer, which when rectified on the low voltage DC board develops about 48 volts, which will be regulated down to power the horizontal scan circuit. That voltage can be adjusted so that we can control the width of the scan. The big monster transformer here provides us with the beginnings of our plus and minus 12 volts. When rectified, it produces about 17 or 18 volts on these two main filter capacitors. Not yet installed will be two 12 volt regulator chips, monolithic regulators, type 7812 and 7912, to give us the system's plus and minus 12 volts at up to 1.5 amps. Those will be mounted to the metal case and attached to the board by their pins on my regular wire connecting loops. This is our scan board, which you should all be familiar with by now. And over here, this blank board will contain the final video amplifier process to feed the output jack, which will be located here. This is the current state of the assembly. The AC power side does work, and I have powered it up to light up the filament in the tube. So in a manner, we have reached first light. Lab guy out.